If we're using a spring to do a job or to do work for us, then it's not a forces question anymore. The force that the spring exerts changes as the spring changes its, in this case, its squishedness. So the spring would exert a particular force at 2 centimeters. We could maybe use that to figure out an acceleration. But as soon as that little car starts to get pushed forward, the spring is at a different length. Therefore, the spring's exerting a different force. Therefore, the acceleration is different. So doing this one with forces would actually be really awkward. A much simpler way is that this is an energy system. When we squish the spring, we load it up with spring potential energy. That energy eventually makes the car move, so that gets converted into the kinetic energy of the car. The 1/2 ks squared of the spring equals 1/2 mv squared of the toy car. Not forces, too ugly, just straight up conservation of energy. In this version of the question, we know everything except the speed of the cars. The 1/2s are going to cancel out. The k that I made up was 40. The s, again, we have to put that in meters. We squished it 2 centimeters, so that's 0.02 meters. And that's equal to our mass of 25 grams. We have to put that in kilograms, so 0.25 multiplied by v squared. Doing a bit of algebra, then taking a square root. This isn't too exciting of a toy. The car only moves at 0.8 meters per second. The concept here was using a spring to do a job or to do some work.